Okay, this is the second video for section 10.2, and we're still going to be focusing on using combinations. We're not going to get to the binomial theorem quite yet. So the first problem says, a popular magazine has 11 articles. You want to read at least 2 of the articles. How many different combinations of articles can you read? Now from the last video, you should probably already know how to do this one. Okay, so you want to read at least 2. Now, at least means maybe 2, maybe 3, maybe 4, maybe 5, maybe 6, all the way up to possibly all 11 articles. So it's a range of situations, hence I'm going to add, okay, so keyword is that it's not just one exact situation, and it's combinations because order doesn't matter. If I read Article A and Article B, or Article B and then Article A, I'm still reading the same 2 articles, and that order doesn't matter. Okay, so I would do 11 choose 2 plus 11 choose 3 plus 11 choose 4. Now at this point I'm going to do ... because you get the idea, all the way up to 11 choose 11. Now if this were a test question, this work would suffice. I don't necessarily think you need to write out every single one. I get the idea. You're going to go all the way up through 11 choose 11. Okay, now type these in your calculator, see what you get. And while I say this, I'm thinking to myself, holy buckets, that takes a long time. But you do get 2,036 ways. Now, I'm going to teach you a shortcut, and it is optional. Okay, so if this shortcut doesn't make sense to you, then don't worry about it. Because if it doesn't make sense, you can do it the long way. The shortcut is this. If you have 2 options, and by 2 options I mean you can either read the article or not read the article, you take 2, because you have 2 options, and raise it to the power of how many articles you have. Okay, so I'm going to do 2 to the 11th power, and again, 2 because I have 2 options, read or not read, raised to the number of articles I have. Then I'm going to subtract everything I don't want. So since I want at least 2, the only thing I don't want here is 11 choose 0 and 11 choose 1. Okay, now I'm going to say this again. Up here I have 11 choose 2 all the way through 11. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The only things I didn't want were 0 and 1. So 2 to the 11th is going to give me 100% of the possibilities. If I take away the 2 things that I didn't want from up here, I'm going to be left with 2,036. And if you don't believe me, type that on your calculator. It's a really slick shortcut. So this is going to give you a large number, and then you're going to subtract 11 choose 0 plus 11 choose 1. Make sure that that's in parentheses, and you should get the same exact answer. Totally optional. You decide if you feel like that benefits you. Okay, you see how you do with this one and if you like to use the shortcut or not. So your school football team has 10 scheduled games for the season. You want to attend at least 4. How many different combinations of games can you attend? So push pause, see how you do. Alright, so if you go the long way, you want to attend at least 4 games. Okay, so at least means 4 or 5 or 6 or 7 or 8 or 9 or all 10. So you do 10 choose 4 plus 10 choose 5 plus blah 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 all the way up through 10 choose 10. And remember, you have 10 games. You want at least 4. If you prefer the shortcut, you have the option to either go to the game or not. So it's 2 options raised to the 10th power because you have 10 games. And then you take away all the ones you don't want. So you wanted 4 through 10, so you don't want 0, 1, 2, and 3. And either way, long way, shortcut way, you get 848. Okay, the last example I'm going to go through is probably the trickier of all the examples, and it deals with cards. So I have all the cards in a standard deck of 52 cards, and we're not going to use the jokers. So I'm just going to cross those out. Whoops. Oh my goodness. Okay, there we go. So first and foremost, if you don't feel like you know cards and it's a test question, please ask me. Like if you don't know how many jacks there are or what the 4 suits are, I will always answer those questions for you. I'm not testing you on your card knowledge. I'm testing you on your probability and your combinations knowledge. So if you don't know that there are 4 suits, clubs, diamonds, hearts, and spades, no problem. If you don't know that face cards are jack, queens, and kings, and there are 12 of those, that's okay. All of those things I would tell you if you wanted to know, okay? So here are the questions. Find the number of possible 5-card hands that contain the cards specified in a standard deck, and the standard deck of cards would be 52. So I want at most 1 heart. So first of all, what does at most mean? That means if I have a 5-card hand, that means maybe one of them is a heart, the other 4 are not, or at most again means maybe just 1, or maybe I don't have any hearts. So no hearts and 5 cards that are not hearts. Okay, so I'm going to remind you this is a range, so I'm going to be adding together the situation. So I'm going to start out with, what if I had 1 heart? Okay, so I might have 1 heart, and then my 4 other cards will not be hearts. Okay, or I might have no hearts, which means my 5 other cards are not hearts, which probably makes sense, right? So what you have to do here, and this is what makes this so tricky, is there are a certain amount of ways you can get just 1 heart and 4 non-hearts, and that's an exact situation, so I have to multiply those together. So how many hearts do you have? There are 13 hearts in a deck. So I'm going to take 13 hearts, choose 1. So 13 hearts, and I want 1, times how many non-hearts. So if you take 52 cards minus 13, that leaves you with 39 non-hearts, and I want 4 of those. Now again, this is going to give me 1 heart and 4 non-hearts. I multiply those together because it's an exact situation. Now, or means add. So adding on to that, what's the chance, or how many combinations of no hearts? So again, I have 13 hearts. How many ways can I get none of those? Well, only one way. Times, how many ways can you get 5 non-hearts? So there are 39 non-hearts, and I want 5 of those. Okay, now, again, 1 heart, 4 non-hearts, or 0 hearts and 5 non-hearts. Now you type all this on your calculator, see what you get. Okay, when you type all that on your calculator, you get 164,5020. So 1,654,020. Just a couple numbers, I guess, if you're curious. This first piece here was 1,069,263, and this number was 575,757. So if you wanted to check those individual numbers. Okay, part B says you want 3 jacks and 2 other cards. Now notice it's and, so it's an exact situation, so this is a little bit easier. So how many jacks do you have in a deck? 4. So I have 4 of them to choose from. How many ways can I order? 3. Then 2 other cards. Well, other cards implies it's not a jack. If I have 4 jacks and 52 cards, 52 minus 4 is 48. So I have 48 other cards, and I have a 5-card hand, right? So if 3 of them are jacks, that means the other 2 are not jacks. Then I'm going to multiply these because I want exactly 3 jacks and 2 other cards. There's not an at most or up to or at least situation about this. Then when you type these on your calculator, 4 choose 3 is 4. And 48 choose 2 is 1,128. And when you multiply those together, you get 4,512 different ways. Okay, part C says you want 5 cards of the same color, and this one's kind of tricky. You can do this 2 different ways. First of all, you know that first you need to know, I guess, is that you have 26 red and 26 black cards, so it's half and half. So the first thing you could do is you could say, okay, I have 2 colors, and I want to choose one. And then once I choose that color, whether it's red or black, who cares, but then you're going to be down to 26 cards, and I want to know how many ways I can get 5 of these. By the way, card questions are always combinations, because if you think about it, if you have 5 cards in front of you, let's say you have an ace, 2, 3, 4, 5, and whatever, same suit. If you switch around those 5 cards, you still have an ace, 2, 3, 4, 5 of the same suit. They just might be in a different order, but that doesn't change your hand of cards, and that probably makes sense to you. Now, 2 choose 1 is just 2, so I want you to think about something. If you just do 26 choose 5, that is 65,780. 65,780. Okay, now that's how many ways you can arrange one color of 5 cards. So like if I had all the red cards and I wanted to pick 5 of them, I'd have this many ways that could happen. If you times it times 2, that's going to take into account that you could also do that with the black cards. So again, you want to get your color first, and then of those 26 cards, choose 5. And when I take that times 2, I get 131,560 ways. Now I'll repeat this, the card questions are tough, so don't get stressed right away. You got to practice these.